Hello everyone and welcome to this channel Lucid Mind Chemistry with Majid. In this video I'll be discussing Chemistry A-Levels Multiple Choice Paper 12 from May-June 2019. You can skip to any question by following timestamps given in the video description. Feel free to give any comments, likes and shares to this video. Also, you can subscribe for more upcoming videos. Let's start solving. Question number 1. The Boltzmann distribution of molecular energies in a sample of aqueous hydrogen peroxide at room temperature is shown. This is the diagram. Which diagram shows the Boltzmann distribution of molecular energies of aqueous hydrogen peroxide maintained at room temperature when a catalyst manganese 4 oxide is added? In this diagram we can see that on x-axis we have molecular energy E. On y-axis we have the proportion of molecules with energy E, and we have the shaded region which shows the molecules with sufficient energy to react. This shaded region actually shows the activation energy of the molecules. So the molecules present in this shaded region can easily convert into products because they have sufficient activation energy. Now, what happens when a catalyst is added? Catalyst actually reduces activation energy. Catalyst does not have any effect on average molecular energies. So therefore there is no change in shape of the curve. The curve shape only changes whenever there is a temperature change. In this question the temperature is kept constant, so only we can see that the activation energy will change. Let's look at the options. We have 4 options here: A, B, C and D. In A and B we can see that the shape of the curve does not change, while in C and D we can see that the curve has shifted in the forward direction. So in C and D there is also a temperature change involved, so therefore they are not the answer. Now let's compare A and B with the question. As we can see that the shape of the curve of A is same and the shape of the curve of B is also same. In A, the activation energy has not changed, it is at the same place as there was in the question. While in B, we can see that now activation energy has decreased. It means that now more molecules will be easily converted into the product as the activation energy has decreased. So therefore, we can see that the correct option is B. Question number 2. Oxygen has 3 stable isotopes, oxygen 16, 17 and 18. All 3 isotopes are present in a sample of oxygen gas, which was analyzed using a mass spectrometer. How many peaks associated with the O2 positive ion would be expected? Now there are 3 different isotopes of oxygen, so they can react with each other in number of phases to form O2 positive ion. The first possibility is that oxygen 16 combines with another oxygen 16 isotope to form oxygen 32 positive ion. Second possibility is that oxygen 16 could combine with oxygen 17 isotope to form oxygen 33 positive ion. Third possibility is that oxygen 16 isotope can combine with oxygen 18 isotope to form oxygen 34 ion. In fourth possibility we have oxygen 17 isotope combining with oxygen 17 to form oxygen 34 ion. In fifth possibility, oxygen 17 can combine with oxygen 18 isotope to form oxygen 35 ion. In sixth possibility, we have oxygen 18 isotope combined with oxygen 18 isotope to form oxygen 36 ion. Now in mass spectrometer we know that the peaks are actually based on molecular masses of the molecules. So therefore different molecular masses will have different peaks. How many peaks associated with oxygen ion would be expected? Let's see how many different molecular masses are there. So this one has 32 molecular mass, 33, 34. Again the molecular mass is same as 34, so this won't give a separate peak. The peak would be the same as this one. Oxygen 35, oxygen 36. So we have 5 different types of peaks that are possible. So therefore correct option is B, 5. Question 3. The first 8 successive ionization energies for 2 elements of period 3 of the periodic table are shown in the graphs. This is the first graph, this is the second graph. What is the formula of the ionic compound formed from these elements? In this graph we can see that there are successive ionization energy. This is the first one, second one, third one, fourth, fifth, sixth, seventh, and you can see there is a larger gap between 7th and 8th ionization energy. So this gap means that the shell has changed. In this graph we can see that there are 7 electrons which have consecutive ionization energies. So therefore it means that this element belongs to group 7 in the periodic table. Now coming to the second graph, we can see that there are 2 successive ionization energies, and then again there is a larger gap between second and third ionization energy. So therefore there is also a change of shell. As there are just 2 electrons removed from the first shell, so it means that this belongs to group 2 of the periodic table. So we have to find the ionic compound which is formed between group 2 and group 7 of the periodic table. Magnesium is from group 2 of the periodic table. Chlorine is from group 7 of the periodic table. Calcium is from group 2. Bromine from group 7. Sodium is from group 1. Sulfur is from group 6. Potassium from group 1. Selenium from group 6. So there are 2 possible options, option A and option B. Now in the question they have given that the elements must be from period 3. So we can see that magnesium is from period 3 and calcium is from period 4. So therefore correct option is A. Question number 4. A sigma bond is made between 2 carbon atoms in a molecule of ethene. Which diagram shows the orbital overlap that occurs to form this bond? In a molecule of ethene we have 2 carbon atoms. They make double covalent bond between them. One of the bond is sigma bond while the other is pi bond. Now sigma bond is formed from straight overlap of orbitals. While pi bond is formed by sideways overlap. The atomic number of carbon is 6. So if we do the electronic configuration, it comes 1s2, 2s2, 2p2. So 2p orbital is involved in the bonding. The shape of s orbital is spherical, while the shape of p orbital is dumbbell shape. In option A we can see that both orbitals are spherical, so this is SS overlap, and as it is straight overlap, so this is a sigma bond. In B we can see there is s orbital, spherical one, and second orbital is p orbital, the one that is dumbbell shaped. This is also a sigma bond because there is straight overlap. In C we have 2p orbitals. There are overlapping straight, so therefore this is making a sigma bond. In D we have sideways overlap of electrons and orbitals, so therefore this shows the formation of pi bond. As in ethene molecule we have both carbon atoms, so both must have p orbitals involved, so therefore C is the correct option. Question number 5. The table shows some properties of 4 substances. Which substance could be potassium iodide? As we know that potassium is a metal and iodine is non-metal. So the bond formed between metal and non-metal is called ionic bond. And therefore this one must show the properties of ionic bonding. Among ionic compounds we have lattice structure, so therefore there is strong electrostatic force of attraction. Which makes the melting point quite high. Also they are bad conductors in solid state because in solid states ions are fixed. While in liquid and aqueous form they are good conductors because ions are free to move. So therefore in these 4 options we can see that A has very low melting point, B also has very low melting point, in C we have high melting point and it is good conductor in molten form. So C could be the possible option. In D we also have high melting point but it is bad conductor in molten state. So therefore D is incorrect. So the correct option is C. Question number 6. X, Y and Z are all gases that behave ideally and react according to the equation shown. This is the equation. 1 mole of X reacts with 2 moles of Y to form 2 moles of Z. When 3 moles of X and 3 moles of Y are placed inside a container with a volume of 1 decimeter cube, they react to form the maximum amount of Z. The final temperature of the reaction vessel is 120 degrees centigrade. What is the final pressure inside the reaction vessel? In this question we can see that 1 mole of X reacts with 2 moles of Y to form 2 moles of Z. So therefore the molar ratio is 1:2, forms 2 moles of product. In the question they have given 3 moles of X and 3 moles of Y. So therefore let's see which one is the limiting reagent. So we have 3 moles of X and 3 moles of Y. Now we can see for 2 moles of Y we require 1 mole of X. So therefore for 3 moles of Y we will require half the amount of 3. So 1.5 will be consumed and 1.5 moles of X will be left behind. So it means X is the excess reagent and Y is the limiting reagent. Now the product also depends on the limiting reagent. So as 2 moles of Y form 2 moles of Z, so therefore 3 moles of Y will form 3 moles of Z. So now the number of moles of X consumed will be 1.5. Number of moles of Y consumed will be 3. Number of moles of Z formed will also be 3. Now to find the pressure, we have the formula PV is equal to nRT, where P is the pressure, V is the volume, N is the number of moles, R is the ideal gas constant and T is the temperature in Kelvin. So P will become P is equal to nRT divided by volume. So in this reaction 1.5 moles of X has completely reacted with 3 moles of Y to form 3 moles of Z. So therefore X and Y are consumed. Only 1.5 moles of X is left behind and 3 moles of product is also left behind after the chemical reaction. So in order to find the total number of moles left after the chemical reaction, we have 1.5 moles of X and 3 moles of Z. So therefore we have 4.5 moles in total. And this is shown by symbol N. Now let's convert the units according to ideal gas equation. We have 1 decimeter cube volume. So therefore this will be converted into meter cube. It will become 1 exponential minus 3 meter cube. Just divide this value by 1000, you will get this value. The temperature is 120 degrees centigrade. Just add 273 to convert it into Kelvin. So we will have 393 Kelvin. Now the value of ideal gas constant from the data booklet is 8.314 joules per Kelvin per mole. We can also write this as 8.314 pascals into meter cube per Kelvin per mole. Now putting all these values in this equation, we have 4.5 moles into 8.314 pascals meter cube per Kelvin per mole. The temperature is 393 Kelvin. The volume of the gas is 1 exponential minus 3 meter cube. Now just cancelling out the units, we have mole, per Kelvin, Kelvin, meter cube with meter cube. So only pascals is left. Now the pressure comes equal to be 1.47 exponential 7 pascals. So therefore correct option is C. Question number 7. Which pair of substances are both simple molecular? A is C60. Now C60 is a molecule of buckyball. It is a simple molecular substance. And graphene is like graphite. So therefore it is not simple molecular, it is giant covalent. In second option we have buckyball and iodine. Now iodine is a simple molecular substance. And there are van der Waals forces present between its molecules, so therefore it is in solid form. So B could be the possible answer. In C we have graphene, which is giant covalent, and graphite. Again graphite is also giant covalent. In D we have graphite and iodine. Graphite is giant covalent and iodine is simple molecular. So therefore correct option is B. Question number 8. A reaction pathway diagram is shown. We have reactants that are reacting together to form the products and products going back to the reactants. So therefore this is a reversible reaction. Which row is correct? Now we can see that one of the arrow is going down while the other arrow is going upwards. Again there are opposite arrows involved. So an upward arrow means that the energy is absorbed or the reaction is endothermic. While downward arrow means that the energy is released or the reaction is exothermic. Now the difference between the reactants and products is the enthalpy change. And therefore K and L are both the enthalpy changes. K is exothermic change and L is endothermic change. Coming to the options, we have to find enthalpy change of the forward reaction. Now we can see that the reactants have high energy as compared to the energy of the products. So it means when we are converting reactants into products, the energy is released. So therefore K is the energy of the forward reaction. So A and B could be the possible options. Second point is the activation energy of the reverse reaction. In reverse reaction, we can see that the products must need this much energy in order to convert back into the reactants. So therefore, the products must absorb energy in order to go to the reactants. So therefore O shows the activation energy of the reaction in reverse direction. You must also remember that the arrow of the activation energy is always in upward direction. So therefore O is correct. So the correct option is B. Question number 9. X is either chlorine or an oxide of chlorine. X reacts with water under suitable conditions to form two acids HCl and HClO3 in the mole ratio of 1:5. What could be X? We can write a chemical equation for this type of reaction. X could be chlorine or oxide of chlorine, so let's make it ClXOY. If it is just chlorine, then the value of Y will be equal to 0. And if it is an oxide of chlorine, then there will be some value of X and some value of Y. Now this reacts with water and it forms HCl and HClO3 in the ratio of 1 moles to 5 moles. Now in the product we can see that HCl has 1 chlorine atom and HClO3 has 5 chlorine atoms. So in total there are 6 chlorine atoms present on the product side. Now looking at the number of hydrogen atoms, we have 5 hydrogen atoms in HClO3 and 1 hydrogen atom in HCl. So in total we have 6 hydrogen atoms. Now balancing the number of hydrogen atoms with the reactants, we can write 3 with H2O to form 6 hydrogen atoms. Now looking at the number of oxygen atoms, we have 0 oxygen atom in HCl and 15 oxygen atoms in HClO3. So we have 15 oxygen atoms in products. On the reactant side, we have 3 oxygen atoms in H2O. So therefore we need 12 oxygen atoms in this compound. In the product we have 6 chlorine atoms. So therefore 6 chlorine atoms are needed on the reactant side. Let's find out the ratio of chlorine atom and oxygen atom in ClXOY. We have 6 chlorine atoms needed and 12 oxygen atoms needed. So the simple ratio could be 1:2. So we can have 6 moles of ClO2, which will balance this chemical equation. So therefore correct option is C, as we have 1:2. Question number 10. Ethyl ethanoate undergoes the following reaction. This is the reaction. Ethyl ethanoate undergoes hydrolysis to form alcohol and carboxylic acid. This Kc for this reaction is given. Kc is 0.27. Equal amounts of ethanoic acid and ethanol were mixed together and allowed to reach equilibrium. At equilibrium, the concentrations of both ethanoic acid and ethanol were 0.42 mole per decimeter cube. What is the concentration of ethyl ethanoate at equilibrium? I'm writing this reaction in the reverse direction. So when I write it in the reverse direction, what happens that the Kc value will also be reversed. So it is C2H5OH reacts with CH3CO2H and forms CH3CO2C2H5 along with H2O. As it is in reversible reaction, so there will be double arrows. The value of Kc will be 1/0.27 as I have reversed the chemical reaction. As we can see, the number of moles of reactants and products are balanced. So we have 1 mole of ethanol reacts with 1 mole of ethanoic acid and it forms 1 mole of ethyl ethanoate and 1 mole of water. So at equilibrium we have equal number of moles. In the question it says that at equilibrium the concentration of both ethanoic acid and ethanol were 0.42 mole per decimeter cube. So let's write the concentration at equilibrium. We have 0.42, 0.42. As number of moles of products are equal, so therefore we can assume that the concentration must also be equal. So we can write X in place of concentration. Now according to the formula of Kc, we have Kc is equal to the concentration of product, which is CH3CO2 C2H5 into H2O divided by the concentration of reactants. We have C2H5OH and CH3CO2H. Putting in the values, we have 1 over 0.27 for Kc, X for ethyl ethanoate, X for water, 0.42 and 0.42 for these two. So it comes equal to X squared divided by 0.1764. Solving it further, we have 1 over 0.27 into 0.1764. It is equal to X squared. Or we can write 0.6533 is equal to X squared. Now taking under root on both sides, we have 0.81 mole per decimeter cube. This is the value of X. So therefore correct option is C, 0.81 mole per decimeter cube. Question number 11, which row is an example of heterogeneous catalysis? Now heterogeneous means that the catalyst must be in different state as compared to the contents of chemical reaction. In A we have esterification reaction. In esterification what happens that carboxylic acid reacts with alcohol and forms ester along with water molecule. So we can see the carboxylic acid is in liquid form, alcohol is in liquid form, ester and water are also in liquid form, and so is sulfuric acid. So therefore this is an example of homogeneous catalysis. B is the contact process. In contact process what happens that sulfur dioxide reacts with oxygen to form sulfur trioxide. All these three are gases. Sulfur dioxide is gas, oxygen is gas, sulfur trioxide is gas, while divanadium pentoxide is solid. So therefore this is an example of heterogeneous catalysis. So this could be the possible option. C is the destruction of ozone layer and it is catalyzed by chlorine radicals. Now in ozone layer what happens that chlorine radical reacts with ozone molecule to form ClO along with oxygen molecule. Now, the chlorine radicals are in gaseous state and so are all the reactants and products. So therefore this is also an example of homogeneous catalysis. D is atmospheric formation of sulfur trioxide and it is catalyzed by nitrogen dioxide. Now the chemical reaction could be written as sulfur dioxide reacts with NO2 to form sulfur trioxide along with NO. As all these are in gaseous state and so is nitrogen dioxide, so therefore this is also an example of homogeneous catalysis. So therefore correct option is B. Question number 12, element Q readily oxidizes in air. The oxide produced reacts with water to form a solution of very low pH. Where could element Q be found in the periodic table? Now solution of low pH means that it is an acidic solution. And we know that non-metal oxide are acidic in nature. Now looking at the options, we have period 2 and group 1. The element is lithium. So lithium is a metal. B is in period 2 and group 14. So the element is carbon. C is period 2 and group 14. So the element is silicon. D is in period 3 and group 15. So the element is phosphorus. As lithium is a metal, so therefore its oxide will be basic in nature. So therefore we can remove this one. B is carbon, and carbon needs oxygen and burning in order to get oxidized. As in the question it says element Q readily oxidizes in air, so therefore it is not carbon because carbon requires combustion. C is silicon. Silicon readily oxidizes in air to form silicon dioxide. Silicon dioxide is weakly acidic. Because it has giant covalent structure and it also does not react with water. The last option is phosphorus. Phosphorus reacts readily with oxygen to form phosphorus pentoxide. P2O5 is acidic in nature as it is a non-metal oxide and also dissolves readily with water to form phosphoric acid. The equation would be like this: P4O10 solid, it dissolves in water to form phosphoric acid, and the pH of this solution is equal to 2. So therefore correct option is D. Question number 13. The 8 elements sodium to argon are in the same period of the periodic table. So we have 8 elements. The equation corresponding to the first ionization energy is shown. One of the electrons is being removed from the gaseous atom to form monopositive gaseous ion. For which of these 8 elements is the electron in this equation removed from a filled orbital? So let's find out the electronic configuration of all these 8 elements first. The elements are sodium, atomic number 11, magnesium 12, aluminum 13, silicon 14, phosphorus 15, sulfur 16, chlorine 17, and last one is argon 18. The electronic configuration of sodium 11 will be 1s2, 2s2, 2p6, 3s1. For magnesium it will be 1s2, 2s2, 2p6, and 1 electron is added, so it becomes 3s2. Then for aluminum this one will be the same, 3s is also the same. Then we have 3p, which has just 1 electron. For silicon again we have 2 p orbitals, 3px, 3py, and each of them has 1 electron. For phosphorus 3px, 1 electron, 3py, 1 electron, 3pz, 1 electron. For sulfur, as the next electron comes in the pair form, so 3px, there will be 2 electrons, 3py, 1 electron, 3pz, 1 electron. For chlorine we can write 1s2, 2s2, 2p6, 3s2, 3px, 3py, 3pz, So 6 and 4, 10 into 12, we have 12 electrons, 13, 14, 15, then we will start pairing 16 and 17. Similarly for argon, all of the shells are complete, so we can write 1s2, 2s2, 2p6, 3s2, 3px, 3py, 3pz, and each of these orbitals has 2 electrons each. Now we have the first ionization energy given in the question. The first ionization energy is the removal of first electron from the outermost shell of an isolated gaseous atom. So let's see which electron is removed from a filled orbital first. So we have 3s. It is not filled orbital because s has 2 electrons in it, so it is not sodium. For magnesium, the electron will be removed from 3s2 as it has 2 electrons, so it is a filled orbital, so this is true. For aluminum, there is just 1 electron in 3p, so it is not a filled orbital, so it's not aluminum. For silicon, the electron is removed from 3py, which is not complete. For phosphorus, the electron is removed from 3pz, again it is incomplete orbital, so it is not a filled orbital. For sulfur, the electron is removed from the paired one first, so it will be 3px, from which the first electron will be removed first. So 3px is a filled orbital because it has 2 electrons. For chlorine atom, we can see again the electron will be removed from a filled orbital first, so the paired electron will be removed first, so it is true. For argon, again all the orbitals are filled, so the outermost electron will be from paired one. So we can see we have magnesium, sulfur, chlorine and argon which have filled orbitals. So therefore answer is C. Question number 14. Elements D and E are both in period 3. Element D has the smallest atomic radius in period 3. There are only 2 elements in period 3 which have lower melting point than element E. Only 2 elements have lower melting point than E. Elements D and E react together to form compound L. Which compound could be L? In the question, they have given that element D and E react together to form compound L. It means that they are reactive substances, so therefore it is not from group 8 in the periodic table, because group 8 consists of noble gases that are unreactive. The second point is that element D has the smallest atomic radius in period 3. So we know that in the periodic table what happens that the atomic radius decreases along the period. Atomic size decreases. This is because of the increase in nuclear charge and the number of shells remain constant. So apart from group 8, we just have one element left, which is chlorine. So element D could be chlorine, because chlorine has the smallest atomic size in period 3. So D could be chlorine. Let's find out about E. In the question, it says there are only 2 elements in period 3 which have a lower melting point than element E. So let's find out the trend in melting point. We can see that in period 3 what happens that the melting point increases from sodium to silicon. This is because of the stronger intermolecular forces of attraction or interatomic forces of attraction. And then we can see that the trend is decreasing from sulfur to argon. So melting point increases for the first half, and then melting point decreases from sulfur to argon. So the only 2 elements which have lowest melting point in period 3 are chlorine and argon. In between this trend, phosphorus has lower melting point as compared to sulfur. This is because phosphorus exists as a molecule of 4 atoms while sulfur exists as a molecule of 8 atoms. And we know that when the number of atoms increase, the size of molecule increase, and when the size of molecule increase, the intermolecular forces of attraction or van der Waals forces also increase. So therefore phosphorus melting point is lower than the melting point of sulfur. So element E could be phosphorus. Now phosphorus and chlorine D and E both react together to form a compound called PCl3, phosphorus trichloride. So therefore the answer is D. Question number 15. How many of the solutions shown when added to a separate portions of magnesium sulfate solution produce a white precipitate? So we have to find out the chemical reaction of all these 4 solutions with magnesium sulfate separately. Let's find out which one makes a precipitate. The first one is HCl. So when HCl aqueous reacts with magnesium sulfate, it forms magnesium chloride along with sulfuric acid. As all of these are soluble in water, so therefore there is no precipitate formed, so it is not HCl. Second is ammonia. Let's find out the reaction of aqueous ammonia with aqueous magnesium sulfate. It forms magnesium hydroxide and ammonium sulfate in the presence of water. Magnesium hydroxide is a white precipitate, so it is in solid form, while ammonium sulfate is a soluble substance. So magnesium hydroxide precipitate is being formed, so therefore it could be NH3. Third one is ammonium carbonate. Now ammonium carbonate aqueous reacts with magnesium sulfate aqueous to form magnesium carbonate and ammonium sulfate. Magnesium carbonate is a precipitate, while ammonium salts are always soluble. So this precipitate is being formed, so therefore ammonium carbonate also produces a white precipitate. Last one is barium nitrate. So let's write the equation of barium nitrate aqueous with magnesium sulfate. It forms barium sulfate and magnesium nitrate. As we know that barium sulfate is white precipitate in solid form and all nitrates are also soluble, so therefore magnesium nitrate is aqueous. So barium nitrate also produces a white barium sulfate precipitate. So among these 4, 3 of them make white precipitate, so therefore answer is D. Question number 16. A white solid Z is soluble in water. A sample of Z is heated with a Bunsen burner until there is no further change. When the residue is shaken with water, a solution is formed with no solid remaining. What could Z be? It says Z is soluble in water, so let's first find out which of the substances A, B, C and D are soluble and insoluble. First one is magnesium carbonate. Magnesium carbonate is insoluble in water. Magnesium nitrate is soluble. As all nitrates are soluble, barium carbonate is insoluble. Barium nitrate is soluble. So therefore the Z could be magnesium nitrate or barium nitrate. Now let's find out what happens when this is heated until there is no further chemical change. So magnesium nitrate when heated on the Bunsen burner produces magnesium oxide along with nitrogen dioxide and oxygen gas. We can balance this chemical equation using this molar ratio. Among the products, magnesium oxide is in solid form, nitrogen dioxide is a gas, oxygen is also a gas. So in the question it says when the residue is shaken with water, a solution is formed with no solid remaining. So among these products, magnesium oxide is solid and it is insoluble in water. So therefore it is not magnesium nitrate. Second option is barium nitrate. Let's first write the chemical equation for barium nitrate. When barium nitrate solid is heated, it forms barium oxide, nitrogen dioxide and oxygen gas. Again we have to find whether barium oxide is soluble in water or not. So barium oxide does dissolve in water. So barium oxide is soluble. Hence barium oxide will form a solution with no solid remaining. So therefore answer is barium nitrate, D. Question number 17. An excess of chlorine was bubbled into 100 cm³ of hot 6 mole per decimeter cube sodium hydroxide. How many moles of sodium chloride would be produced in the reaction? Let's first find out the number of moles of sodium hydroxide used. As we know that concentration is equal to number of moles divided by volume in decimeter cube, or number of moles is equal to concentration into volume in decimeter cube. So concentration is given, it is 6 mole per decimeter cube. Volume is 100 cm³, or we can convert it into decimeter cube. It will be 100 divided by 1000 decimeter cube. Decimeter cube will cut out with decimeter cube, so the answer is 0.6 moles. Now let's write the balanced equation between chlorine and hot sodium hydroxide. We have Cl2. It reacts with hot NaOH and forms sodium chloride, sodium chlorate along with H2O. Start. In the balanced equation, the molar ratio used is 3, 6, 5, 1 and 3. Now we have two reactants, one is chlorine, second is sodium hydroxide. In the question it says in excess of chlorine was bubbled, so therefore chlorine is in excess. So sodium chloride is only dependent on the limiting reagent, so therefore sodium hydroxide could be the limiting reagent. We can see that the molar ratio between sodium hydroxide and sodium chloride produced is 6:5. In the question, they have given 0.6 moles of sodium hydroxide, so therefore 0.6 moles of sodium hydroxide will produce how many moles of sodium chloride? Let's just cross multiply. So we have 6x is equal to 5 into 0.6, or x is equal to 5 into 0.6 divided by 6. So the answer is 0.5 moles. So therefore B is the correct option. Question number 18. Ammonium sulfate and ammonium nitrate are used as fertilizers. These salts have different percentages by mass of nitrogen. They have same effect as each other on the pH of wet neutral soil. Which row is correct? So we have to find out the higher percentage of nitrogen by mass and effect on pH of soil. Let's first find out the molecular mass of these two compounds. First one is ammonium sulfate. We have 2 nitrogen atoms, 8 hydrogen atoms, 1 sulfur, 4 oxygen. So it will be 2 into 14, 28 for nitrogen, 1 into 8, 8 hydrogen, 1 into 32 for sulfur, and 4 into 16 for oxygen. So the molecular mass is 132. Now let's find out the percentage of nitrogen. We have 28 molecular mass of nitrogen. So the percentage of nitrogen is equal to 28 divided by the total molecular mass, which is 132, into 100. So the percentage of nitrogen comes equal to 0.212%. So percentage of nitrogen is 0.212 in ammonium sulfate. Let's do the same for ammonium nitrate. We have NH4NO3, 2 nitrogen atoms, so 2 into 14, 28, 4 hydrogen atoms, 3 oxygen atoms. So the molecular mass comes equal to 80. Now let's find out the percentage of nitrogen in this compound. So percentage of nitrogen will be atomic mass of nitrogen, which is 28 in this compound, divided by total molecular mass of compound into 100. So it comes equal to 0.35%. So we have 0.35% of nitrogen in ammonium nitrate. So the higher percentage of nitrogen by mass is ammonium nitrate, so therefore A and B could be the possible options. Now let's find out the effect on pH of soil. In the question they have given that both of these compounds have the same effect as each other on the pH of wet neutral soil. First one is ammonium sulfate. Ammonium sulfate, when dissolved in water, it produces ammonium hydroxide and sulfuric acid. Now sulfuric acid is a strong acid, so it will decrease the pH of soil. Same is true for ammonium nitrate. Ammonium nitrate, when dissolved in water, forms ammonium hydroxide and nitric acid. Again, nitric acid is a strong acid and ammonium hydroxide is a weak base, so therefore the effect on pH will be that the pH will decrease. So the correct option is A. Question number 19. Which reaction gives a product that is an atmospheric pollutant causing acid rain? Now the atmospheric pollutant which can cause acid rain must be a gas that is soluble in water and also acidic in nature. In the first one we have magnesium sulfide solid and magnesium oxide solid. Both are solids, so therefore they are not gases. In B we have ammonia gas, which is basic in nature, so it is not acidic gas. Again, calcium sulfate is solid and water liquid, so therefore these are not the correct options. In C we have manganese ion, H+ ion and sulfate aqueous. Again, none of them are gases. In D we have iron oxide solid, sulfur dioxide gas, sulfur trioxide gas. Now sulfur dioxide and sulfur trioxide are both acidic gases which dissolve in water to form sulfurous acid and sulfuric acid respectively. So therefore D is the correct option. Question number 20. 3-methyl-but-1-ene can undergo different types of reaction. Which row correctly identifies the reaction types? Let's first find out the names of these compounds. This is 1, 2, 3, 4. On third carbon we have methyl group attached, so it is 3-methyl-but. The double bond is on in between first and second carbon atom, so it is but-1-ene. Let's find out the name of this product. We have 1, 2, 3, 4 carbon atoms in the long chain, and on second carbon we have methyl group, so it is 2-methyl butane. As we have single bonds and there are 4 carbon atoms in the long chain. Let's find out the name of the third compound. We have 1, 2, 3, 4. On first and second carbon atom we have 2 chlorine atoms, and on third carbon atom we have methyl group. So the name will be 1,2-dichloro 3-methyl butane. In reaction 1 we can see that the only change is that alkene changes into alkane. So alkene actually needs hydrogen in order to change into alkane, so the addition of hydrogen is actually called reduction. Hydrogen is added to the double bond and double bond converts into single bond. So reaction 1 is reduction, so it could be C or D. In reaction 2 we can see that 2 chlorine atoms are added on the double bond. So if this is the double bond, then what happens that partial charges are developed on chlorine molecule, and then the electrons of the double bond, they actually attack the positive center of the chlorine molecule and it gets converted into dichloro compound. This is because alkenes have high electron density because of the presence of double bond. Such type of reaction is called electrophilic reaction, and as chlorine atoms are added on the double bond, so therefore it is electrophilic addition. So correct option is C. Question number 21. Compound X does not show cis-trans isomerism. What could be the identity of compound X? In order for a compound to show cis-trans isomerism, there must be 2 conditions that should be followed. One is that the compound must have a double bond. And second is that there must be different elements attached with the carbon atom that is doubly bonded. A is 1,1,2-trichloropropene. Now let's find out the structure of this compound. We have propene, so 3 carbon atoms. Trichloro, so there are 3 chlorine atoms. One is on first carbon, second is also on first carbon, third is on second carbon. So 1, 1, 2, trichloropropene. And the double bond is in between first and second carbon atom. Let's find out the conditions. For condition 1, we have a double bond, so yes, condition 1 is met. For condition 2, there must be different elements attached with the double bonded carbon. So we can see both elements are chlorine, so therefore they are the same elements, so condition 2 is not met. So therefore it does not show cis-trans isomerism. So it could be the possible option. Second is 1,2,3-trichloropropene. Again we have 3 carbon atoms for propene, and chlorine atoms are attached with first, second and third carbon respectively. So we have chlorine, 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 and the double bond could be on either side. Now with the first carbon atom we have 3 bonds, the fourth bond is being formed with hydrogen. On second carbon atom we have 4 bonds, on the third we have 2 hydrogen atoms. So let's find out the conditions. First condition is that there must be a double bond. Yes, there is a double bond. Second condition is that there must be different elements or compounds attached with the double bonded carbon. So we have different with the first one, different with the second one. So both conditions are met. So therefore B shows cis-trans isomerism. so it is not the possible option. Let's find out about C. C is 1-chloro-but-1-ene. So we have 4 carbon atoms. As it is 1-ene, so therefore the double bond is in between first and second carbon. And 1 carbon also consists of chloro, 1 chloro. Now rest of the hydrogen atoms, we have 1 hydrogen with this one, 1 with this, 2 with this, and 3 with this one. Now let's find out the condition. First condition is double bond. So yes, we have a double bond. Second condition is that different elements are attached. Chlorine and hydrogen are different. Again, hydrogen and this is the different. So therefore both conditions are met and it shows Cis-Trans isomerism. So therefore it is not the option. Let's find out the last one. It is 1-chloro-but-2-ene. So again we have 4 carbon atoms in the long chain, and on second carbon we have double bond as it is 2-ene. On first carbon atom we have chloro, 1 chloro, rest of the hydrogen atoms. Let's find out the conditions. First condition is met as there is a double bond. For second condition, 1 is hydrogen, 1 is this, 1 is hydrogen, 1 is this. So we can see both the carbon atoms, this one and this one, have different types of elements and compounds attached. So therefore both conditions are met. So it is an example of Cis-Trans isomerism. So the only possible option is A. Question number 22. The diagram shows the repeat unit of an addition polymer. What is the correct name for the monomer that would form this polymer? So we have to find out the monomer of this compound. Now the easy way to find out a monomer of an addition polymer is that you have to remove these bonds and the central bond will become a double covalent bond. So we can write C double bond C, C2H5, CH3, CH3, C2H5. This is the monomer of this polymer. In order to name this monomer, we must first find out the long chain consisting of the double bond. So we can see that this is actually the long chain. We have 1, 2, 3, 4, 5, 6 carbon atoms in the long chain. And we also have a double bond, so it is hexene. Now let's find out the substituents and the position of double bond. 1, 2, 3, 4, 5, 6. So on third carbon atom we have methyl group, on fourth carbon atom again we have methyl group, and on third carbon atom we have double bond. So we can write 3, 4 dimethyl, hex 3-ene. Also we can see that the same compounds are attached to the opposite side of the double bonded carbon atom. For example, C2H5 is on this side, and for second carbon atom we have on this side. Similarly, methyl group is attached on this side and then on the opposite side of the second carbon atom. So it shows a trans compound. So we can write trans 3,4 dimethyl hex 3-ene. So therefore correct option is D. Question number 23. A molecule of geraniol is shown. You can see that we have double bond, 2 double bonds and 1 hydroxyl group attached at the end. What is formed when geraniol is added with excess of cold dilute acidified manganate ions? So you have to remember that whenever cold dilute acidified manganate ions is added to an alkene, what happens that diols are formed on the double bonded carbon atoms. Diols means two OH groups. Each on the double bonded carbon atom. There is no effect of cold dilute acidified manganate on the OH group. So we can see that the double bond is converted into single bond and diols are formed. So we have two OH group on this bond and double bond is converted into single one. Same as for the second double bond, we have two OH groups attached with the double bonded carbon atoms and double bond will be converted into single covalent bond. There is no effect on this OH group. Let's move towards the options. In option A, we can see that two OH groups are attached. Also, double bond is converted into single bond. Again, two OH groups are attached and double bond is converted into single bond. And OH not affected. So, therefore, correct option is A. Question number 24. Alcohol W cannot be made by reducing carboxylic acid with lithium aluminum hydride. Alcohol W gives only one product when dehydrated with concentrated sulfuric acid. What could be the identity of W? Now we know that carboxylic acid, when reduced, it converts into aldehyde, which further reduces to primary alcohol. As the question it says, alcohol W cannot be made by reducing a carboxylic acid with lithium aluminum hydride, so it means it is not a primary alcohol. Let's first find out which one of them is primary alcohol and which is not. A is butane 1-ol, so we have 4 carbon atoms and OH is attached to the first carbon atom. Second is butane 2-ol. Again we have 4 carbon atoms and OH is attached to the second carbon. In C we have 3 carbon atoms and OH is attached to the first carbon. In D we have OH attached to the second carbon. Now primary alcohol means such an alcohol in which OH group is attached to the carbon atom and this carbon atom is directly attached to 1 or 0 carbon atoms. Now we can see this carbon is attached to just one carbon atom, so it is primary alcohol. In the second part we can see OH is attached to this carbon atom and this carbon is directly attached with 2 other carbon atoms. So therefore it is not primary, it is secondary alcohol. Third one, we can see that the carbon atoms attached with OH is directly attached to one carbon atom. So again this one is primary alcohol. For D, we have this carbon atom which is attached with OH and it is further attached to 2 carbon atoms, so it is secondary alcohol. As we know that W is not primary alcohol, so we can cross out A and C. Second part of the question says that alcohol W gives only one product when dehydrated with concentrated sulfuric acid. So let's see if B and D, which gives one product. So dehydration means removal of water molecule in the presence of concentrated sulfuric acid. Now for the removal of water, we can see that OH is removed from one carbon atom and hydrogen atom is removed from adjacent carbon atom. So it could be this carbon or hydrogen atom could also be removed from this carbon. So therefore 2 different types of products are formed. Either it could be this one, in which hydrogen is removed from first carbon and OH is removed from second carbon, or this one, in which OH is removed from second carbon and hydrogen is removed from third carbon atom. This first compound is but1-ene, second is but2-ene. Now for D part, we can see that OH is removed from central carbon atom and hydrogen can be removed from this adjacent carbon or from this adjacent carbon. So we can write it like this. Either the double bond is in between first and second carbon atom, or it could be between second and third carbon atom. Now let's find out the names. We have prop1-ene, and again the double bond is present on first carbon atom, so therefore this is also prop1-ene. So as similar product is formed, so therefore only one product is considered. So therefore correct option is D. Question 25. Which product can be made from bromoethane by elimination reaction? Let's first draw the structure of bromoethane. We have two carbon atoms. On one carbon we have bromine atoms and rest are hydrogen atoms. Now elimination means the removal of a molecule. In this case, bromine is removed from one carbon atom and hydrogen is removed from adjacent carbon atom, and double bond is formed instead of single bond. So the product will be carbon-carbon double bond along with the removal of HBr. So we can see an alkene is formed from bromoethane, and this alkene is 2-carbon alkene, so it is ethene. So the correct option is B. Question number 26. Propene, bromine and hydrogen bromide are mixed in the dark. A number of products are formed, some in very small quantities. Which substance will not be present in the mixture of products? So we have propene, bromine and hydrogen bromide. Now dark means that there is no radical substitution, free radical substitution is involved. Let's see how these products are formed. A is 1-bromopropane. Now propene can react with HBr in an addition reaction, and hydrogen will be attached to one carbon atom and bromine is attached to the second carbon atom. So we could have this product. And the name is 1-bromopropane. So this product is a possible one. For second, we have 2-bromopropane. Now again the propene can be a reactant. It can react with HBr, and this time bromine will be attached to the central carbon atom and hydrogen is attached to the corner carbon atom. So it can make this product. And the name is 2-bromopropane. So this is also a possible addition product of HBr on alkene. Third one is 1,1-dibromopropane. Now we can take propene and add bromine in it. What happens that one of the bromine atom will be attached to one double bonded carbon atom. Second bromine atom will be attached to the other double bonded carbon atom. So the product will be like this. Br on this carbon atom and Br on this carbon atom. So the product is 1,2-dibromopropane. So this is also a possible product. So we can see that 1-bromopropane can be formed, 2-bromopropane can be formed, 1,2-dibromopropane can also be formed. but there is no way that bromine atom will be attached to one carbon atom. Both bromines cannot be attached to single carbon atom having a double bond. So therefore C is not possible. So correct option is C. Question number 27. Which reagent could be used to distinguish between ethanol and propanol? Now ethanol and propanol both are aldehydes. In ethanol we have 2 carbon atoms. In propanol we have 3 carbon atoms. Let's see how can they be distinguished from each other. A is 2,4-DNPH or 2,4-dinitrophenylhydrazine. It gives positive result whenever a carbonyl carbon is present. Now as carbonyl carbon is both present in aldehyde, both these aldehyde, so therefore both will give positive result with this product. So we cannot distinguish by 2,4-DNPH. We can draw the structure of ethanol like this: CH3, C double bond O, H, and propanol will be like this: CH3, CH2, C double bond O, H. Now B is iodoform test, presence of iodine and sodium hydroxide. Now iodoform test is always positive whenever there is CH3, C double bond O present. As we can see that in ethanol there is CH3, C double bond O present, but in propanol there are 2 carbon atoms with C double bond O. So ethanol will give a positive result with iodoform test, and propanol will not give any test with iodoform. So therefore B could be used to distinguish between ethanol and propanol. C is potassium dichromate in the presence of sulfuric acid. As it is a strong oxidizing agent, so both ethanol and propanol will be oxidized to carboxylic acid groups. So both cannot be distinguished by this test. D is Tollens reagent. Both of these compounds are aldehyde, so therefore both give positive result with Tollens reagent. So only iodoform test can be used to distinguish between ethanol and propanol. Question number 28. The diagram shows that a carboxylic acid P may be formed from X, Y or Z. In the diagram we can see alcohol X converts into carboxylic acid. Now this is only possible when alcohol is primary alcohol, because primary alcohol first converts into aldehyde, and aldehyde further oxidizes into carboxylic acid. If it is a secondary alcohol, then it does not convert into carboxylic acid because it will convert into ketone. In the options we can see that alcohol X should be primary, so it could be A or B. It is not C or D. And we also have to find the change in molecular mass which is greatest. Let's take an example of 1 carbon primary alcohol. So we have CH3OH. It will be converted into aldehyde, which will be HCHO, and it is converted into carboxylic acid P, which is HCOOH. So for this conversion of aldehyde into carboxylic acid, we have HCHO, 1 carbon aldehyde, and it converts into HCOOH, which is 1 carbon carboxylic acid. Now Z is a nitrile, and nitrile can also be converted into carboxylic acid upon acid hydrolysis. Let's find out which molecular mass change is the greatest one. Now the molecular mass of CH3OH is 32, HCHO is 1 plus 12 plus 1 plus 16, 30. For HCOOH we would have 46. Again for aldehyde we have 30. For carboxylic acid we have 46. For nitrile we have 27. Now we can see that the change from aldehyde to alcohol is 16. And from nitrile to alcohol is 19. So therefore greatest change is from nitrile to carboxylic acid or Z to P. So therefore correct option is B. Question number 29. One molecule of compound R is shown. This is a compound of R. We can see that the functional group is of ester. What is the name of compound R and how does its boiling point compare with that of butanoic acid? So we have to find out the name and the boiling point. Now in the structure of ester, the first part comes from alcohol, while the second part comes from acid. So we have 3-carbon alcohol which is going to form this compound R. So the alcohol should be propanol. While we have 1-carbon acid that is going to make this compound R. So the acid is methanoic acid. So when propanol and methanoic acid combine together, we will have propyl methanoate. So the correct option could be C or D. Now we have to find out the boiling point, whether it is higher than butanoic acid or lower than butanoic acid. In order to find out the boiling point, you must remember that carboxylic acids have hydrogen bonding among them, while esters does not have any hydrogen bonding. Therefore, the boiling point of carboxylic acid is always higher than corresponding acid. So this ester would have lower boiling point than butanoic acid. So therefore correct option is D. Question number 30. The diagram shows the infrared spectrum of Q. This is the infrared spectrum. On x-axis we have wave number per centimeter and on y-axis we have transmittance. We can find out the structure of the compound by the help of these peaks. So one of the peak is at 3000 while the other is at 1700 plus. So we can write 3000 and 1700, a little bit more than 1700. Stop. Start. What could Q be? Let's find out which compound is this one. A is butane 1-ol, so we have 4 carbon atoms and alcohol is on first carbon atom. As this is alcohol, and according to data booklet, in alcohol the OH functional group corresponds to 3200 to 3600 sharp peak. As there is no such peak present in this compound, so therefore it is not butane 1-ol. B is butanoic acid. In butanoic acid, we have 2 different peaks corresponding to carbonyl carbon and OH group. Now the carbonyl carbon peak will be between 1680 to 1730 sharp, while the peak of OH group for butanoic acid will be between 2500 to 3000 sharp and broad. As we can see, only carbonyl carbon peak is present at 1700 plus and there is no broad peak between 2500 to 3000, so therefore it is not butanoic acid. C is butanone, so this is ketone. In ketone we just have carbonyl carbon present and the peak will be between 1670 to 1740, sharp and strong. This is the only peak that is present in butanone, as in this graph you can see that the sharp peak is present at 1700 plus, so it could be butanone. Last one is 3-hydroxybutanol. So it is aldehyde, and on third carbon we have hydroxyl group attached. Again, there are two peaks corresponding to this one. One is from OH group and second is from carbonyl carbon. The peak for OH must be between 3200 to 3600 sharp, and the peak corresponding to carbonyl carbon should be between 1670 to 1740 sharp. As this peak is absent, so therefore it is not 3-hydroxybutanol, so the only option that could be correct is C. Question number 31. When oxygen reacts with hydrogen sulfide, the products are sulfur dioxide and water. Mixture Y contains an equal number of two molecules shown and no other molecules. So only this molecule is present and this molecule is present. Which statement about Y are correct? Number 1, the average molecular mass in Y is 34. Let's find the molecular mass of these two molecules. So oxygen 16 plus oxygen 18, so the molecule MR will be 34. For sulfur we have 32 plus 1 hydrogen plus 1 hydrogen, so the molecular mass of hydrogen sulfide is also 34. So as the number of molecules are equal, so therefore the average should also be equal to 34. So option 1 is correct. In 2, if some oxygen molecules are removed from Y, the average MR of the mixture remains the same. As all molecules have molecular mass 34, so if some of the molecules are removed, the average will still be 34. So it is also correct. Third part says when mixture Y is ignited, some hydrogen sulfide remains unreacted. Let's find out the chemical reaction on ignition. So the mixture of Y consists of hydrogen sulfide and oxygen gas. It forms water and sulfur dioxide. Let's balance this chemical equation. On product side we have 3 number of oxygen atoms, so we can write 3/2O2. So the molar ratio is 1:1.5 for hydrogen sulfide and oxygen. So for 1 mole of hydrogen sulfide we need 1.5 moles of oxygen, so it means hydrogen sulfide is in excess, so it is left unreacted. So part 3 is also correct. So all 3 parts are correct. So the answer is A. Question 32. Which statements about an atom of technetium-99 are correct? The atomic number of technetium-99 from periodic table is 43 and the nucleon number is 99. Part 1. It has 13 fewer protons than neutrons. Now protons are 43 and neutrons will be 99 minus 43, 56 neutrons. If we add 13 in 43, it becomes 56, so therefore 1 is correct. Second option, it forms technetium plus 2 which has 45 electrons. Now in neutral technetium we have 43 electrons. When it becomes plus 2 charge, it means 2 electrons are removed, so it must have 41 electrons instead of 45, so therefore this is wrong. 3. It has 56 nucleons. As we can see in the symbol, we have 99 nucleon numbers, so therefore it is not 56, it is 99. So 3 is also incorrect. So only correct option is 1, so therefore the answer is D. Question number 33. In which reactions are nitrogen atoms reduced? Now let's find out the oxidation state of nitrogen in NO2 and N2. In NO2 we can see that we have one nitrogen atom, two oxygen atoms, and overall charge is 0. So the charge on one oxygen atom is -2, so for two oxygen atom it will be -4. So nitrogen will be equal to +4. This nitrogen is in molecular form, so the oxidation state is 0. The oxidation reduction can be remembered from this number line. If oxidation state goes in the forward direction, it means it is oxidation. If oxidation state goes in the backward direction, for example +1 to 0 or 0 to -1, so then it will be reduction. As in the first one, it goes from +4 to 0, so it is reduction, so therefore this is correct. In option 2, we have +4 oxidation state of nitrogen on the reactant side, and on the product side we have +1 oxidation state. So +4 to +1, again this is reduction, so it is correct. In part 3 we have +4 oxidation state, and in ammonia, as hydrogen is less electronegative, so the oxidation state of one hydrogen atom will be +1. So for 3 hydrogen atom it will be +3. And for nitrogen it must be -3. So +4 to -3, again we are going in the backward direction, so it is also reduction. So all three options are correct, so therefore answer is A. Question 34. The manufacture of ammonia from nitrogen and hydrogen is an important industrial process. Which of the following would leave the equilibrium constant Kp for the formation of ammonia unchanged? Now you have to remember that in order to change Kp, there must be a change in temperature. So only temperature can change the equilibrium constant Kp value. No other thing can change the equilibrium constant. So the addition of iron as a catalyst will not change Kp. Addition of ammonia will just change the concentration, it will not change Kp. Increase in pressure will also not change Kp. So all three options are correct. So the answer is A. Question number 35. Which reactions involving calcium and its compounds produce two gaseous products? First one is heating solid anhydrous calcium nitrate. So we can write the chemical equation. Calcium nitrate, it decomposes to form calcium oxide along with nitrogen dioxide and oxygen gas. Calcium oxide is in solid state, so NO2 and O2 are the only gaseous products formed. So therefore option 1 is correct, as it forms two gaseous products. Second is heating solid anhydrous calcium carbonate. So we can write the chemical equation CaCO3. It decomposes to give calcium oxide and carbon dioxide. Calcium oxide is solid, so the only gas is CO2. So therefore one gaseous product is formed, so it is incorrect. Third is adding calcium metal to water. Now calcium reacts with water to form calcium hydroxide, and this is a very slow reaction along with the production of hydrogen gas. So only one gaseous product is there, so therefore this is also incorrect. So only one option is correct, so therefore answer is D. Question 36. A small quantity of hot concentrated sulfuric acid is added separately to solid samples of potassium halides. Which potassium halide reacts and produces a mixture of products that include a halogen X2? One is potassium iodide, so we have potassium ion and iodide ion. Second is potassium bromide, so we have K plus Br minus and K plus Cl minus. Among the halide ions, we can write F minus, Cl minus, Br minus, I minus. The reducing ability increases down the group. So it means fluoride and chloride cannot reduce sulfuric acid. Concentrated. Br- can reduce sulfuric acid. And it can form sulfur dioxide. And Br- is itself oxidized to bromine. For iodide ion, it can also reduce sulfuric acid. Iodide ion can form a mixture of products including hydrogen sulfide, sulfur dioxide, and I- is itself oxidized to iodine. The chemical equation would be like this. For potassium bromide, we can write the products as potassium hydrogen sulfate along with bromine, sulfur dioxide, and water. For potassium iodide, the products would be potassium sulfate, hydrogen sulfide, sulfur dioxide, iodine. For potassium chloride, the reaction will produce potassium sulfate and hydrochloric acid. So we can see that the mixture of products along with halogen is only formed in KBr and Ki. So correct options are 1 and 2. So therefore answer is B. Question number 37. The diagram shows a compound used as a flame retardant. This is a compound. Which statement about this structure are correct? 1. The empirical formula is C2H3Br. Let's find the empirical formula. Each corner represents carbon atom. So we have $12 carbon atoms, 6 bromine atoms, and rest are the hydrogen atoms, as each carbon is making single covalent bonds. So one hydrogen with this one with this, 2 with this, 2 will be with this, 1 with this, 2 with this one. So in total there are 18 hydrogen atoms. So the molecular formula is C12Br6H18. Let's find the simple ratio. So we can have 2 carbon atoms, 1 bromine atom, and 3 hydrogen atoms. So C2H3Br is the empirical formula, so it is correct. Option 2 says the carbon 12 ring is not planar. Now this is quite a large ring, so therefore in order to be stabilized it will be a twisted structure. So it is not planar. This is also correct. Option 3, there are 6 chiral carbon atoms. Let's find the number of chiral carbons. Now chiral carbon is such a carbon that is attached to 4 different elements or groups. Let's find out among these 12 carbon atoms which is attached to 4 different elements or groups. Now this is the first carbon. It has 1 bromine atom, 1 hydrogen atom. One is this whole chain attached on this side, and one is this chain attached on the other side. So therefore this is chiral as all 4 groups are different. Again, for this carbon atom, we can see we have one hydrogen atom, one bromine atom, and a long chain on this side and a long chain on this side, and both chains are also different, so therefore this is also chiral. For this third carbon, you can see it has 2 similar hydrogen atoms, so it is not chiral. Same is for the fourth one. Then this carbon is also chiral. This is also chiral. Similarly, this carbon and this carbon is also chiral. So in total we have 6 chiral carbon centers, so therefore option 3 is also correct. So answer is A. Question number 38. Halogenoalkanes can be hydrolyzed using aqueous sodium hydroxide. Which compounds tend to be hydrolyzed by an SN1 mechanism? Now, in order to follow the SN1 mechanism, the halogenoalkane must be a tertiary halogenoalkane. Let's draw the structures of these 3 given compounds, and then we can find out which one is primary, secondary or tertiary halogenoalkane. So first one is carbon, then second carbon, then third carbon, then chlorine is attached with the third carbon atom, CH3 is also attached with the third carbon atom. Then we have fourth carbon, CH2, then the last carbon, CH3. So it will be Cl and CH3. Now we can find out whether the halogenoalkane is tertiary by looking at the halogen. This Cl halogen is attached to this carbon atom, and this carbon is directly attached with 3 other carbon atoms, so therefore this is tertiary structure. So it will be hydrolyzed by SN1 mechanism. Now let's draw the second one. We have 1 carbon, 2 carbons, 3 carbons, 1, 2, 3, and with the third carbon bromine is attached and CH3 is also attached. Then we have CH2 and CH3. Again we can see that the halogen is attached to this carbon atom and this carbon is directly attached with 3 other carbon atoms. So therefore this is also tertiary halogenoalkane, and it will undergo through SN1 mechanism. Let's draw a third one. We have 1, 2, 3 carbon atoms, and this CH3 is attached with this carbon atom. Then fourth and fifth carbon atom, fourth and fifth, and then this bromine is attached to this last carbon. Now we can see that the halogen is attached to this carbon atom, which is further attached to just 1 carbon atom directly. So therefore this is primary halogenoalkane. It will undergo through SN2 mechanism. So therefore this is incorrect. So option 1 and 2 are correct. So therefore answer is B. Question 39. In an organic synthesis, a 62% yield of product is achieved. Which conversions are consistent with this information? Let's first find out the molecular masses of butane 2-ol, butanone, butane 1-ol, butanoic acid, 2-methyl-propane 1-ol and 2-methyl-propanoic acid. So butane 2-ol is like this. And the molecular mass of this compound will be, there are 4 carbon atoms, 10 hydrogen atoms, 1 oxygen atom, 48 plus 10 plus 16, it will be equal to 74. Second is butanone. So MR is, there are 4 carbon atoms, 8 hydrogen atoms, 1 oxygen atom, just adding these 3 we have 72. Then we have butane 1 ol. Again, in order to find MR, we have 4 carbon atoms, 10 hydrogen atoms, 1 oxygen atom. So again the MR is equal to 74. Then we have butanoic acid. There are 4 carbon atoms, 8 hydrogens, 2 oxygens. So the molecular mass is 88. Now we have 2-methylpropane 1 ol. Four carbon atoms, 10 hydrogen atoms, and 1 oxygen atom. So MR is 74. And for the last one, we have 2-methylpropanoic acid. So in total there are 4 carbon atoms, 8 hydrogen atoms, 2 oxygen atoms. So the molecular mass is 88. Now let's find the number of moles of each substance. We have 74 grams of butane 2 ol, so the number of moles will be mass in grams divided by molecular mass, which comes equal to 1 mole. Similarly, for butanone we have 0.62 moles. For butane 1 ol again we have 1 mole. For butanoic acid we have 0.62 moles. For this one we have 1 mole. And for 2-methylpropanoic acid we have 0.62 mole. Now in order to find percentage yield, we have moles of product divided by moles of reactant into 100. So for all of them it will be 0.62 divided by 1 into 100, which comes equal to 62%. So all 3 options are correct. So therefore answer is A. Question number 40. An oxidizing agent that can oxidize ethanol to ethanoic acid or ethanoate ions will also oxidize methanoic acid to carbon dioxide and water. Which reagents on heating will react differently with HCO2H and CH3CO2H? As ethanol is aldehyde, so therefore we can consider this one as aldehyde because it will react similarly. Second one is carboxylic acid. One, we have sodium carbonate as we know that carbonate reacts with acid to form salt and water, along with the production of carbon dioxide gas. As this is carboxylic acid, this is also carboxylic acid, so both will give the same result. Second is Fehlen's reagent. Fehlen's reagent can oxidize aldehyde. So therefore HCO2H will also be oxidized. While Fehlen's reagent cannot oxidize carboxylic acid. Third is dilute acidified KMnO4. It is also an oxidizing agent and it oxidizes aldehyde. So therefore it can also oxidize HCOOH. And it cannot oxidize other carboxylic acids. So therefore 2 and 3 will react differently with both HCO2H and CH3CO2H. So therefore 2 and 3 are correct. So option C is the correct answer. Thanks for watching. A like, comment and subscribe will be highly appreciated. You can find related videos in playlists. Stay happy and enjoy learning.